Welcome to our comprehensive guide on building a narrow AI system. In this video, we'll walk you through the essential steps and best practices to create an effective, focused artificial intelligence solution. Narrow AI, also known as weak AI, is designed to perform a specific task or solve a particular problem, unlike general AI, which aims to replicate human intelligence broadly. Whether you're a beginner or an experienced developer, understanding the fundamentals of narrow AI is crucial for success in today's technology-driven world. Let's dive in and explore what it takes to build a robust narrow AI system. Before you start building, it's important to clearly define what narrow AI is. Narrow AI systems are designed to excel at a single task, such as language translation, image recognition, or playing chess. They operate within a limited context and cannot perform tasks outside their programmed domain. This focus allows for high efficiency and accuracy in specific applications. By understanding the boundaries of narrow AI, you can better plan your project and set realistic expectations for its capabilities and limitations. First practical step in building a narrow AI system is to identify the specific problem you want to solve. This could be anything from automating customer support to detecting anomalies in financial transactions. Clearly defining the problem helps you focus your resources and design a solution tailored to your needs. Take time to research the problem space, understand the requirements, and gather input from stakeholders. Well-defined problem statement sets the foundation for a successful AI project. Once you've identified the problem, it's time to set clear, measurable objectives for your narrow AI system. Objectives should be specific, achievable, and aligned with your overall business goals. For example, if you're building a chatbot, your objective might be to reduce customer response time by 50%. Setting clear objectives not only guides your development process, but also provides benchmarks for evaluating success. Make sure your objectives are realistic and consider any constraints such as budget, time, or available data. Data is the backbone of any AI system. For narrow AI, collecting high-quality, relevant data is especially important. Start by identifying the types of data you need, such as images, text, or numerical values. Ensure your data is representative of the problem you're solving and covers various scenarios the AI might encounter. Clean and pre-process your data to remove errors and inconsistencies. Remember, the quality of your data directly impacts the performance of your AI model. After collecting your data, the next step is annotation. Data annotation involves labeling your data so the AI system can learn from it. For example, if you're building an image recognition system, you'll need to label images with the correct categories. Accurate annotation is crucial for training effective models. Consider using annotation tools or outsourcing to experts if your dataset is large. Consistency and accuracy in labeling will lead to better AI performance. Selecting the appropriate AI model is a critical decision. The choice depends on your problem type and data. For tasks like image classification, convolutional neural networks are popular, while natural language processing often uses recurrent or transformer models. Evaluate different algorithms and consider factors such as accuracy, speed, and resource requirements. Experiment with several models before settling on the one that best fits your needs. With your data prepared and model selected, it's time to train your narrow AI system. Training involves feeding labeled data into the model so it can learn patterns and make predictions. Monitor the training process closely, adjusting parameters as needed to improve performance. Use techniques like cross-validation to ensure your model generalizes well to new data. Remember, training is often an iterative process that requires patience and careful tuning. After training, it's essential to validate and test your AI model. Use a separate dataset that the model hasn't seen before to evaluate its performance. Look for metrics such as accuracy, precision, recall, and F1 score to assess how well your model performs. Testing helps you identify any weaknesses or biases in your system. Make adjustments as needed and repeat the process until you achieve satisfactory results. One common challenge in AI development is overfitting, where the model performs well on training data but poorly on new data. To avoid this, use techniques such as regularization, dropout, and data augmentation. Regularly evaluate your model on unseen data and keep your model as simple as possible for the task. Balancing model complexity and performance is key to building a robust, narrow AI system. Upper parameters are settings that control the learning process of your AI model. Tuning these parameters, such as learning rate or batch size, can significantly impact performance. Use systematic approaches like grid search or random search to find the optimal values. Keep track of your experiments and compare results to identify the best configuration for your narrow AI system. Feature engineering involves selecting and transforming input variables to improve model performance. This step can include creating new features, scaling data, or encoding categorical variables. Good feature engineering can make a significant difference, especially in narrow AI systems where the focus is on a specific task. Experiment with different techniques and use domain knowledge to guide your choices. Choosing the right evaluation metrics is essential for measuring your AI system's success. Depending on your task, you might use accuracy, precision, recall, F1 score, or area under the curve. Select metrics that align with your objectives and provide meaningful insights into model performance. Regularly review these metrics to track progress and identify areas for improvement. Building a narrow AI system is rarely a one-shot process. Iterative improvement is key to achieving the best results. After each round of training and testing, analyze the outcomes and make adjustments to your data, features, or model. This cycle of refinement helps you gradually enhance performance and adapt to new challenges as they arise. Once your narrow AI model is performing well, it's time to plan for deployment. Consider the environment where your AI will operate, such as cloud, edge devices, or on-premises servers. Plan for integration with existing systems and ensure your deployment strategy supports scalability and reliability. Early planning helps avoid surprises and ensures a smooth transition from development to production. Integrating your Narrow AI system with existing business processes is a critical step. Work closely with it and operations teams to ensure seamless connectivity and data flow. Address compatibility issues and test the integration thoroughly before going live. Good integration ensures your AI system delivers value and operates reliably within your organization. After deployment, continuous monitoring is essential to maintain performance and catch issues early. Set up monitoring tools to track key metrics and system health. Monitor for data drift, unexpected errors, or changes in user behavior. Proactive monitoring allows you to respond quickly and keep your Narrow AI system running smoothly. Over time, the data your AI system encounters may change, leading to model drift. This can reduce accuracy and effectiveness. Regularly retrain your model with new data and update features as needed. Establish a schedule for reviewing performance and retraining to ensure your Narrow AI system stays relevant and accurate. Security is a top priority when deploying AI systems. Protect your data and models from unauthorized access or tampering. Use encryption, access controls, and regular audits to safeguard your Narrow AI system. Stay informed about emerging threats and update your security measures as needed to keep your system safe. Ethics play a crucial role in AI development. Ensure your Narrow AI system operates fairly and transparently. Avoid biases in your data and model and respect user privacy. Establish guidelines for responsible AI use and regularly review your practices to align with ethical standards. Building trust is essential for long-term success. Incorporating user feedback is vital for continuous improvement. Set up channels for users to report issues or suggest enhancements. Analyze feedback to identify patterns and prioritize updates. Engaging with users helps you refine your Narrow AI system and ensures it meets real-world needs. Thorough documentation is essential for maintaining and scaling your Narrow AI system. Document your data sources, model choices, training procedures, and deployment steps. Clear documentation makes it easier for others to understand, maintain, and improve your system over time. Invest time in creating comprehensive and up-to-date records. Building a successful Narrow AI system often requires collaboration across multiple disciplines. Encourage open communication between data scientists, engineers, domain experts, and stakeholders. Regular meetings and shared tools help keep everyone aligned and foster a culture of teamwork. Collaboration leads to better solutions and smoother project execution. Version control is not just for code, it's also important for data models and configurations. Use tools like Git to track changes and maintain a history of your project. This makes it easier to roll back to previous versions and collaborate with team members. Good version control practices help prevent errors and ensure reproducibility. As your Narrow AI system grows, scalability becomes important. Design your architecture to handle increased data volume and user demand. Consider using cloud services or distributed computing to support scaling. Planning for scalability from the start helps you avoid bottlenecks and ensures your system can grow with your needs. Optimizing performance is key to delivering a responsive and efficient AI system. Profile your code and model to identify bottlenecks. Use hardware acceleration, parallel processing, or model compression techniques to speed up inference. Regularly test and optimize to ensure your Narrow AI system meets performance requirements. Managing costs is an important aspect of AI projects. Monitor resource usage and optimize for efficiency. Choose cost-effective infrastructure and consider open-source tools where possible. Regularly review expenses and adjust your approach to stay within budget while maintaining quality. Ensure your Narrow AI system complies with relevant laws and regulations. This includes data privacy, intellectual property, and industry-specific requirements. Consult legal experts as needed and keep up to date with changing regulations. Compliance protects your organization and builds trust with users. Great user experience is essential for adoption and satisfaction. Design intuitive interfaces and provide clear feedback to users. Test your system with real users and iterate based on their input. Focusing on user experience ensures your Narrow AI system is accessible and valuable to its audience. Make your Narrow AI system accessible to all users, including those with disabilities. Follow accessibility guidelines and test your system with assistive technologies. Inclusive design broadens your user base and demonstrates a commitment to equality and usability. AI is a rapidly evolving field. Stay up to date with the latest research, tools, and best practices. Encourage your team to participate in training, conferences, and online courses. Continuous learning helps you keep your Narrow AI system at the cutting edge and ready for future challenges. Leverage open-source tools and frameworks to accelerate development and reduce costs. Popular libraries like TensorFlow, PyTorch, and Scikit-learn offer robust features and community support. Evaluate tools based on your project needs and contribute back to the community when possible. Cloud services provide scalable infrastructure and powerful tools for AI development. Platforms like AWS, Azure, and Google Cloud offer managed services for data storage, model training, and deployment. Assess your needs and choose the right cloud solutions to support your Narrow AI system efficiently. Automate repetitive tasks in your AI development workflow to save time and reduce errors. Use tools for data preprocessing, model training, and deployment automation. Automation streamlines your process and allows your team to focus on higher value activities. Protect your data and models with regular backups and a solid recovery plan. Use automated backup solutions and test your recovery procedures periodically. Being prepared for data loss or system failures ensures your Narrow AI system remains reliable and resilient. Robust error handling is essential for a stable AI system. Anticipate potential issues and implement strategies to handle errors gracefully. Log errors for analysis and provide meaningful feedback to users. Effective error handling minimizes downtime and improves user trust. Automated testing helps ensure your Narrow AI system remains reliable as it evolves. Implement unit tests, integration tests, and end-to-end tests for your code and models. Continuous testing catches issues early and supports rapid development cycles. Implement comprehensive logging and analytics to track system behavior and user interactions. Analyze logs to identify trends, troubleshoot issues, and optimize performance. Good analytics provide valuable insights for ongoing improvement of your Narrow AI system. Managing changes in your AI system is crucial for stability. Establish clear processes for proposing, reviewing, and implementing changes. Communicate updates to all stakeholders and document changes thoroughly. Effective change management reduces risk and ensures smooth transitions. Engage stakeholders throughout the AI development lifecycle. Regularly update them on progress, gather their feedback, and involve them in key decisions. Strong stakeholder engagement ensures your Narrow AI system aligns with business goals and delivers real value. Identify and assess potential risks early in your project. Consider technical, operational, and business risks. Develop mitigation strategies and monitor risks throughout the project. Proactive risk management helps you avoid surprises and ensures project success. Encourage knowledge sharing within your team and organization. Hold regular knowledge sharing sessions, document lessons learned, and create resources for future projects. A culture of sharing accelerates learning and improves overall project outcomes. Design your Narrow AI system with future needs in mind. Build modular components, plan for updates, and stay adaptable to new technologies. Future-proofing ensures your system remains relevant and easy to upgrade as requirements evolve. Take time to celebrate milestones and successes with your team. Recognizing achievements boosts morale and motivates everyone to continue striving for excellence. Celebrate both big wins and small victories as you build your Narrow AI system. Congratulations on reaching the end of our guide to building a Narrow AI system. We've covered every step, from defining your problem and collecting data to deploying, monitoring, and improving your AI solution. By following these best practices, you'll be well equipped to create effective, reliable, and ethical Narrow AI systems. Stay curious, keep learning, and continue refining your approach as the field evolves. Thank you for joining us on this journey.